online models which improve and personalize people's education, which perfectly fits the goal of dance. Today is going to present MOOClets, which are modular components of online courses that can be modified to create different versions that can be iteratively improved and personalized based on experimental comparisons that identify what is better and for whom. As usual, if you're watching the talk live, you have the opportunity to post questions in the Hangout, in the Q&A part, that will be discussed with the speaker after the talk. And if you're watching a recording, please join the discussion on our website under Dance CS CMU EDU. And now, without further ado, I'm handing over to Joseph. Hey, Joseph.
Hi, everyone. So thanks a lot for Carolyn and Oliver for organizing this. It's a great initiative, and it's great to be able to give a presentation here. So I'm going to switch to sharing my screen, but just to introduce myself, as Oliver mentioned, I'm Joseph. I'm originally from Trinidad and Tobago in the Caribbean. So I'm telling you because some people say they often miss my presentation trying to figure out where this strange accent is from. So now that I've told you, I've hopefully given away the mystery, and now you have your full attention. Okay, so I'm just going to pull everything up. Okay, play from start. Great. So Oliver, let me know, but I think now it should actually be showing all of my slides.
Yes, I can see the slides.
Okay. So as one thing I'll say is I included some hyperlinks. josephgerms.com/MOOClet kind of has links to the most recent work or most recent incarnation of these ideas. And that link tying .cc Williams talk, I'll just put a link in there afterwards, the slides and so on, but I guess Oliver will also have them. And one thing I should say before starting is that this is actually a kind of atypical talk, and it's even atypical for me because most of my research in the past has focused on particular experiments, like in online environments like Khan Academy or edX, or even machine learning, which is often proposing a particular model or solution. But actually, the work I'm presenting today is actually a framework. And you know what it means to be a framework in this sense is a sort of conceptual, a set of concepts and ways of designing technology so that it actually enables other people to do research. So in a way, when you're looking at this, the evaluation really is actually not necessarily whether particular experiments or results seem to be advancing some conclusion, but actually the way you evaluate a framework is if it leads to fruitful research. So as you're watching this, you know, I'd be very curious to your thoughts on how do these concepts help you? How do they help you do research on data mining? How do they help you do research on improving education resources? And in particular, this framework is really based on my experiences trying to run experiments in a wide range of online environments, and especially trying to connect together a couple groups. One is instructors, or the people who have to make practical decisions, so that when we're doing research, we're actually improving the experience for them. Another is researchers who want to run experiments and compare different versions of instruction, like different messages to motivate people or explanations. And the third group is actually machine learning researchers. So people who would really like to build algorithms into online technologies so that they're intelligent and constantly changing. And the final group is actually the engineers, the ones who basically have to make all this happen within online technologies. And a big part of what I think the MOOClet formalism that I'm present does is provide a very simple way for people to implement technologies and think about technologies so that we can actually achieve the goals of instructors, of experimental researchers and machine learning researchers in a way that helps students. So I'd be very interested, especially after the talk, if you'd like to contact me, if you have suggestions for how this framework can be useful or how it might actually enable other people in doing their research. Okay, so before actually getting to the content of the talk, I'd just like to start with a concrete example. Here's one kind of use case for the MOOClet framework. What I've done is looked at basically said, well, if you give me an online education platform, for example, assessments.org, which presents lots of middle school students with math exercises, or if you give me an education platform like edX.org, which I think all of you are familiar with, how can we actually systematically set this up so that we can actually make improvements to the platform that make instructors happy, but also collect the data and allow the kind of workflow that lets us discover fundamental generalizations about how people learn. And so what I actually see the MOOClet formalism is actually a kind of solution to this problem. So here's an example of something that is common in both of these platforms and most, is a math problem or any kind of problem. You might give a statement like, in assessments, student might get a problem like, Mary's music store had 5 truckloads of CDs delivered. Each truck dropped off 12 boxes. Each box has C CDs. Writing special for how many CDs were delivered. Now, this is kind of a bit of a building block of most online education. We always give people problems and we ask them to solve these problems. You'll see problems of this form, although often more complicated in edX, in the assignments, in the quizzes, everywhere. So how can we actually now help students in solving these problems? Well, one thing that's, again, very common across all platforms is to give explanations or hints. So within assessments, and Khan Academy, if you click a button, it'll give you a hint about how to solve this problem. Within edX, you might click and the action might just give you a full solution or a full explanation. And so in this case now, what the MOOClet is actually this explanation or hint. So without getting too much into technical detail, because I'll do that, the idea is that this is going to be a MOOClet, or can be set up through MOOClet, because when we give an explanation, for example, one explanation could be, take the problem step by step, and it starts explaining the details of how to solve this problem. We should also be able to actually give a second explanation, or a third, or a fourth. So the idea is that what makes this a MOOClet is that it's a point in the platform that we identify where you can actually make different versions of it. Instructors are open to different versions being made. Researchers want to test different versions in order to advance some scientific question, and the technology actually allows these to be delivered. It sounds like a very simple thing, but actually in many of these platforms, at least my experience has been, that's often a technical barrier. Now, being able to present different versions, that's not really enough. What we actually really want is also a set of data associated with each of these sort of MOOClets. So for example, if you were to think about the data you'd want to have associated when you're delivering different explanations to different students, you'd, of course, as a researcher, want to specify, well, what condition are they in? Are they going to be in condition A or B of your experiment? It might be useful to have information like someone's pre-test score. What did they do before? What is their motivation level? And now this set of data associated with a MOOClet, in this case just an explanation, will also actually have post-test measures. It'll have accuracy on subsequent problems, and it might also actually just tell you how much time they spent on this. A third component that actually these MOOClets have is actually something like a rule set. So this is basically a way for someone who's external to the platform to specify a way of delivering these different versions of an explanation based on variables like what conditions someone's been assigned to, or actually based on features of users. So I kind of dumped a lot there, but I think the main upshot of this is to say, here's one example of a MOOClet that I've implemented, where I would just take components of assessments and edX, and I would set them up so that we can make different versions of explanations, let's say, and we can actually get data in real time about how people are responding to them, as well as data about the people who are encountering these explanations. And there's the ability to specify in a way that doesn't involve diving into the code, kind of an abstraction, what the rules are for delivering different versions of explanations based on features of people or even experimental variables like condition. So I just want to give you a concrete example you can think through. So in terms of what the talk's going to cover, I think the key idea that I'd like to get across is that when you set up a platform so that you break it up into these modular components or these MOOClets, there's actually a formal definition for what it means to implement something as a MOOClet. And once you satisfy this definition, you can basically think of MOOClets like explanations of how to solve a problem, explanations of a concept, videos, messages, as basically serving multiple functions for different people. For instructors, these are like targets for improvement. An instructor can say, well, I'd like to see the explanations for these problems improved. I'm open to seeing different versions. They also function as laboratories, because a psychologist or an education researcher could say, well, I'm going to design different versions of these explanations to test some hypothesis about learning or motivation. And I'm actually going to get ready in real time to be able to conduct an experiment in a real world setting with students that would be very different if I just did in a lab. And then finally, these MOOClets, even though it's a very simple thing like an explanation of multiple versions, they are also function as intelligent agents because there's a wide range of machine learning algorithms that can be applied so that there's automatically adapting the rules for presenting different versions of a MOOClet, different versions of explanation, say, based on features of students. Oops. Oliver, is that you messaging me there? Oh, okay, I'll assume not.
No.
Okay. How is the speed and everything?
It's fine. Great.
It's fine. Okay, great. Another is that MOOClets actually enable some very useful methodologies. One of them is discovering how we should personalize. I know it's a buzzword, but how should we give different people different instruction based on features like their level of knowledge or their motivation? So MOOClets kind of enable us to use experiments to discover how we can personalize. Another is that they provide a lot of analytics and data in real time, and especially allow instructors to know what data is being provided and ensure it's private, but also provide researchers with a very transparent look at what they will get from a particular experiment. A big part of this, as I mentioned, is how they can align instructors and researchers, how they provide an abstraction for reinforcement learning. So I'll discuss that more, but basically, without knowing anything other than something's a MOOClet, there are a lot of machine learning algorithms that a practitioner can apply off the shelf. But the big benefit is that it allows a lot of the scientists who work on machine learning and reinforcement learning to actually now start to collaborate with us. And one thing I'll mention if people are interested is that there's a NIPS workshop, Neural Information Processing Systems, this December 12th in Montreal, and that's actually on this topic of basically how can you bring together machine learning algorithms with user technologies in education and health. So if you're interested, feel free to contact me, or I'll have the information on my website. But you should feel free to submit abstracts to participate if you're in education, if you do machine learning, if you do some analytics to combine them. And then finally, how this actually now is something you can go to an engineer. I think a basic idea of the MOOClet framework is actually every time we implemented A/B testing, we could have done it as MOOClets, and if we'd done that, we'd have been able to do so much more. And I'll discuss that more, but anytime someone's implementing the capacity to A/B testing, the MOOClet formalism can actually be a design pattern where by default, the way most platforms implement, and the way I even myself implemented experiments in the past, doesn't enable us to do personalization and machine learning. But if you do it using a MOOClet, any experiment implemented within a MOOClet will also, for free, give you a lot more flexibility in terms of actually being able to adaptively personalize. And then finally, one thing I'll just close on as a direction I'm now beginning to explore is how MOOClets can serve as a focal point for crowdsourcing and continual improvement. I think the key idea here is that when we build an online course, we don't necessarily know exactly what form it's going to take in the end. We don't know what we're trying to optimize about students. Is it immediate learning, long-term learning? But by designating things as a MOOClet, it's basically giving us the flexibility where we can keep coming up with new versions. We can keep actually coming up with new algorithms for delivering different versions to different people. And we can actually change what we're trying to optimize or how we're trying to personalize. And so this is actually a framework for sort of flexible deployment, where we don't have to know in advance, but we can actually learn over time how to help students. So just to talk more formally about a MOOClet, because you might hear the term and think it's just any kind of modular component of a platform. There's actually a specific formalism, like a set of necessary and sufficient conditions. And these kind of guide the process. So as I mentioned, you might just look at edX or any website, and it's sort of a blank wall. You know, what components of this could I change? Technology-wise, but also instructional-wise. What are even good components to change? And so the key idea with the MOOClet is let's actually take a particular platform. If you give me a platform, edX, Assessments, Coursera, NovoEd, let's actually restructure it so that we decompose into these modular pieces that each independently able to be varied, but then actually share data amongst themselves. So for example, MOOClet could be which of several versions of a video is presented, what text shows up on a page to explain a concept, if people are solving math problems, like experiments I've done in Khan Academy and assessments in edX. What motivational message we show above a problem could be a MOOClet. What explanations or hints we give someone. So a MOOClet is a designated component for the definition of a technology, like a lesson, an exercise, a hint, if and only if it's been redesigned to meet these criteria. The first is that alternative versions can be delivered using if-then rules. So a researcher or an instructor could write these rules out separate from the platform implementation without any code. These rules are going to basically take as input a list of variables associated with the user. This could be any data about the user's behavior, what they did yesterday when they last entered the course. It could be a characteristic, like what they said in the pre-course survey was their attitude towards learning. It could also be experimental variables, which would be defined by a researcher or an instructor external to the platform. The rule set can be dynamically modified via API. And so this is really critical. And it's actually something that falls out very easily from implementing as a MOOClet. The key idea here is that instead of just running an experiment, you might just specify rules for an experiment, and then later on you can actually change these. So you can put more people in one condition than another, or you could actually transition from experimenting, where you're presenting people to conditions randomly, to actually personalizing, where you give people the explanation that's best for their level of knowledge, let's say. And finally, the user variable list also has to be able to be modifiable. So you can actually add variables to the user variable list, like experimental variables, or you can modify the values. So you can actually update estimates of what people know. And this can be done either via an external API or via any other MOOClet. So I've actually talked about it as if a MOOClet was one thing, like one explanation. And I think that's actually one powerful way to implement them. But the real power comes when you take an entire platform course. And I've done this in Edge, where I basically took an entire edX course, and I actually then decomposed all of the pre-course surveys, all of the lessons, the problems into MOOClets. So each of these now can be independently changed. And they also feed data back to a central user variable store. So I actually have a huge amount of information about each student, but each of those is its own intelligent agent. It can adapt to show different messages, different hints, different problems, and so on. So to give a concrete example, oops, one second. So to walk through that a bit more, you can imagine MOOClet 1, like this explanation of these messages, which has two versions. And you might specify in the rule set or policy, well, okay, something simple. If you're in condition A, then show version 1. If you're in B, then show version 2. So these variables are now coming from this user variable store, which has information like condition, pretest score, but also is going to be adding in measures like what score someone gets on a quiz the next week. On the other hand, now, the way this is set up, you could also have written a rule set that did personalization or tailoring. I'm using these words very loosely here, but all I really mean is giving someone something different based on some user characteristic. So for example, if the pretest was less than 50%, then let's show version 1. If it was greater than 50, let's show version 2. So the kind of key idea is, once you designate a MOOClet and you make multiple versions, you can ask whether one of these works better than the other, but you can also ask which of these works better for which people. So in a way, that's kind of not quite for free, but anytime you make different versions of a resource, you can keep improving, not just by seeing what works, but finding more and more ways in which one explanation might work better for students with different characteristics. As I mentioned, this kind of formalizes an equivalent between randomized experiments and personalization. So if you've got user variable store, here's another example of information, like whether the learner's goal is to get a certificate or just to audit the course, an experimental condition. Whenever we are in a MOOClet, it's sort of enforcing this equivalence between experimentation and personalization. When we're experimenting, what we're doing is presenting one version of an explanation versus another based on a variable that was set randomly. We just set A and B randomly by flipping a coin. When we're personalizing, this is actually just the other side of the coin. It's on a continuum. We're actually just presenting one version versus another based on a feature of a user. Like people who want to get a certificate, get explanation 1, or people who wanted to audit, get explanation 2. here's another example of MOOClets. Not just explanations, but maybe reflective questions. What questions do you show on the video to make people think? So here's an example of one implementation that I've done. In fact, the one I mentioned earlier, where you give people a problem, and then you actually give them different explanations. So to actually flesh this out, what I did was take problems from assessments and from edX, and I gave actually a pretest. So within the MOOClet, it's actually getting information from either from an external data source or another MOOClet that was 3 or 4 problems measuring knowledge. I also then asked students, well, how well do you think you'd be able to understand how to solve problems like the following problem and would be able to solve them correctly? So this is getting into details of what are user characteristics that might be useful in these contexts. Then, of course, there's the problem statement, and then there's an explanation or hint. In terms of outcome variables, I actually then asked people to rate how helpful each hint was. So the idea here is that not just looking at learning, but actually trying to get a really close signal that can give us direct feedback on which hints people find helpful. As another step, I actually prompted people to explain in their own words what this step was saying. And that's going to come in and be useful later on. But the kind of key idea here is that because we've got this way of just actively collecting data, and because it's very easy, within a MOOClet at least, to swap in new explanations, new hints, I'm actually trying to learn a source, collect explanations from people, which might then actually be sent to other people. And then, of course, we follow this up with a post-test to measure learning. So I'm actually not going to get into the details of these studies. I'm actually working on them right now for a paper, but also because the main test of this, I think, is not this particular study. I'm sure many people here could actually come up with better ones, but could this kind of approach be useful for research that you might be doing? So I'm presenting this mainly as a concrete illustration of how you would use the MOOClet framework. So because this is all set up in real time to allow people to contribute, what you're seeing here actually is a Google spreadsheet. This is just how I implemented it, where each of those versions of the explanation is actually just represented here in text. So this explanation or hint is actually coming or being pulled in real time from there. And I'm sticking to text at the moment just because that's, as a psychologist, that's what I can see as being very easy to change, but still having a big impact, how you explain something. So what's happening right now in the study we're running is that we're putting in different explanations. The first one came from the instructor. The second one was one I wrote based on research. And actually, the third came from a learner. So when learners were actually trying to re-explain hints in their own words, we actually pumped those back in after vetting them. And I said I wouldn't present the results, but just to give you a sneak preview, what we're actually kind of finding is that explanations written by the instructor work really well for learners with high knowledge, but actually explanations that are written by other students may actually be helping learners with low knowledge learn more. And of course, there are also interactions where what someone's actually learning, what's actually helping them on a post-test is actually different from what they rate as having been helpful. So this is all just a kind of gesture to how when you sort of take a component of a course and set it up in this way as a MOOClet and you have this data come in real time, this is just a systematic kind of approach where we can now open up a whole set of different questions. I think the kind of key idea here is that we're not, we basically are conducting research or collecting data to take actions. Everything that we do is centered around, should we be presenting this version or that version? Whereas I know the approach can typically be more to collect data, do data mining, and then propose a study. I think the key idea of a MOOClet is that it makes it a lot easier for anyone to start off experimenting from the get-go. So one thing you'll see here is that I actually have 5 versions. So even though 3 are running right now, there's actually space for 4 or 5. And this, again, is really easy to implement. All I have right now in the MOOClet rule set is just if statements that are never activated. They just never show version 4 or 5, which is good because there's nothing there right now. But what this means is that as time goes by, as new ideas arise from another instructor, from students themselves, we can actually then weave these into experimentation. So typically with an experiment, you start with your conditions and you run that through all the way. within something like a MOOClet, you've got this adaptive dynamic experimentation, where the idea is that experimentation shouldn't be, it doesn't have to just be a scientific tool that we register a study and run it. It's actually an extension of normal practice. Instead of presenting one version to 100% of students, let's present different versions to different students with some proportion. And right now, 0% of students get version 4 or 5. But as we get new ideas, as over time we have new insights or new ways of explaining things, we can actually then pipe these in smoothly without any change to the underlying infrastructure. In terms of actually now what is being provided in real time, this MOOClet, this explanation is piping data back to this user variable store. So every one of these lines is a participant, and the instructor ahead of time knows, okay, this is the data that's being made available to my students. Pretest problem accuracy, their rating of how well they could solve problems or understand problems like this, which version of the explanation or hint they got, their rating of the hint, and then the post-test problem that they solve. So just to kind of remind you, this is basically taking what's here and mapping it to this data being output. And again, this is a real-time system. As a quick side note, the way I do this is basically within edX and any platform, the normal trend is that data is passed to the platform and then researchers come and get it. What's actually happening here is that data is being sent two ways. It goes to edX, it goes to systems as usual, but it also pipes a limited set of the data to this user variable store. So what that means is that data is available in real time for analysis, for scientific analysis, but also actually for adaptation. So it's pretty much making this MOOClet an intelligent agent and a mini lab where we can, based on this data, adapt things in real time. As you can see, there's also transparency. None of this information is PII. The instructor can basically look at these variables and know exactly what's going to researcher. The researcher can, ahead of time, as soon as one subject has been run, know exactly what data is there. It might again seem like a small thing, but at least in my experience, running things with Khan Academy, edX, Moodle, any platform that's built for content is not going to necessarily provide data that you want. And I've spent months just waiting on data to be sent through no fault of anyone. It's just that you basically don't necessarily have a platform that's built for adaptation or built for research. And so as I mentioned, the rule set isn't a condition on these user variables. So the idea here is that there's a set of if-then rules that might say things like, okay, if you're assigned explanation version 2, then show X. If you're assigned to 3, then show Y. But they can actually also now start to things like say, well, if you have a low pretest accuracy, if your rate of understanding is high or low, then you should go to this version. Or they can do combinations. If you've got low knowledge, but you rate your understanding high, then you need an explanation that's really simple. And so on. As I mentioned, this enables instructor-researcher collaboration because they've got this focal point where they're modular components that they kind of agree are these zones where things can be changed. And so the idea here is we're not using experiment just as a scientific tool, but actually almost as a conceptual tool to enable collaboration. By specifying different versions and how they might impact different variables, we can actually align instructors and researchers in collaboratively designing experiments, or even just reviewing experiments so that we can rapidly come to agreement about what should be run and what shouldn't. Oliver, I just want to check in. How am I on time? I have about 20 minutes on my watch.
Yeah, so we're at the half-hour mark.
Oh, yeah, okay, so a lot more than that. Okay, so maybe I'll try and wrap up in about 10.
Yeah.
Okay.
Great.
10:15. Okay, I'll try not to run over.
Sure.
So far I've discussed how the MOOClet framework might be helpful for instructors, for experimental researchers, for getting data in real time. What's also a key feature of how I built this, given my background in machine learning, computational cognitive science, is actually thinking, well, how can we use this idea that we're making different versions and we're experimenting, personalizing, to also enable another class of researchers to help in this process? And these are machine learning researchers. In particular, reinforcement learning is one class of machine learning algorithms that I'm going to talk about concretely. The key idea behind reinforcement learning and MOOClets is that we basically want algorithms that will automatically experiment. A researcher might specify the versions, an instructor might specify what variables to optimize for, like accuracy on the next 5 problems versus accuracy on a end of exam or certification rate. But then the algorithms are basically then the ones that determine how to experiment, how to explore, and try and discover new ways to personalize. So the basic reinforcement learning approach is to say, well, you got an agent, and it can be in any one of a set of different states in the environment. There's a set of actions the agent can take at any time, and when it takes an action, there are rules for going between states. There are rules that determine the reward when you enter a state, and the rules that describe what they observe. So I'm going to talk about a very simple version just for the purposes here, which is if you think of the state space or the observed variables, these are different combinations of user characteristics. So for a MOOClet, if a MOOClet is formally equivalent to reinforcement learning agent and a wide range of them. But the thing that's the intelligent agent, because it's so strange to think of an explanation as an intelligent agent. What is that explanation doing exactly? Well, in a way, what it's doing is saying, well, I'm in a state where a user has just shown up and is about to receive an explanation. And the state I'm in is basically that the user is male or female. They have a low or high pretest score. They said they got question 1 right last week. They spent 4 hours on the site last Friday. All of these variables are basically state space. And so the agent now has to decide, well, based on these variables, what version should I assign to someone? And the reason reinforcement learning is so relevant here is because it tackles what's called the exploration and exploitation trade-off. If you've got 5 explanations, you want to explore, you want to assign some of these randomly so that you can actually see what's working well on average and what's working well for who. At the same time, once you're learning what's working, you don't want to just keep experimenting because the goal is not just to get generalizable knowledge, the goal is also to help students. So the user variable store also provides a state space here. The action space are the alternative MOOClet versions that can be delivered, like different versions of a motivational message. The reward function, what the agent's trying to optimize, are chosen measures of learning or engagement that could be specified by the instructor or researcher. Quiz score, final exam, even course satisfaction, which to be honest is actually what we often have to optimize for in MOOCs. The policy now is what actions you take based on the state space and user characteristics. Now, what I've just outlined here is basically saying if you speak to any researcher who does work on multi-arm bandits, contextual bandits, market decision process, POM-DPs, all you have to say to them is, this lesson is implemented as a MOOClet. There are X versions. Here's the list of variables. Of course, they're going to want to know more, but that's actually just enough for them to, in real time, give you a policy for how to experiment. And as data comes back after every participant, they can actually keep updating that policy in real time without any changes to infrastructure. While what actually has happened often is that people might implement a technology, collect a lot of data using a randomized policy where they're just trying everything out. Then they go back, they do offline learning, then they propose a new policy. Instead, in real time, you can actually be adjusting it on every single data point because the MOOClet allows you to change, using these if-then rules, what happens in real time without any changes to the underlying infrastructure because it provides this abstraction. So just provide one concrete usage scenario, and this is again with an email. And I just want to reinforce that I think the things that everyone listening here can come with are much more interesting. I'm really excited about looking at those. But this is just, I chose it because it gave a nice illustration. Basically, an instructor came to me and said, I'm sending out emails to people in a MOOC. I'm trying to get them to give me feedback on the course, and here's my goal. I'd like to increase the response rate. So the instructor has a reward function. How many people respond to an email? They've got an optimization problem. How do we actually choose these emails so that we can maximize response rate? So we have to learn what emails work, but also you've got a lot of side information. Maybe some emails work better for people in certain age groups or people who've been active for different lengths of time in the course. So what I said is, okay, well, let's actually set up this MOOClet as an email. Let's set up this email as a MOOClet. And so then, as I mentioned, this reward function of whether someone responds or not is binary. As a state space or context vector, we had up to 50 variables. Just for simplicity, I'm just showing you what we did for just 2, which was age group, a discrete variable, and then number of days active, 0, 1, or 2 or more. The action space here now was different versions of the email. And so in terms of policy, what we started out was basically A/B experimentation, randomized assignment. Then we actually switched to a hybrid of experimentation and personalization, where we were basically continuing to assign people randomly. So we always were collecting data, but we started to put more people in those conditions that were working well. And we started to put more people in the conditions that were working well for their age group or the people, how many days people like them had been active. So I should be clear, when I say personalization here, it's a broad term. I don't mean personalization within a person. I actually mean personalization in the sense of from between subjects. So if someone has a certain age group and we get a brand new person in that age group, what should we do to them? Should we do something different for them if they're 18 to 22 versus 23 to 26? I do actually have other projects now where we're doing it within people, but for now, this is what I'm focusing on. Now, one thing I should say is, well, where do you get all these versions? And I think this is where I found the sort of concept of MOOClet to be useful in bringing together researchers. Someone who's a machine learning person may not necessarily have an idea of how to generate different versions, but this is something where you can then outsource a task to a psychologist, to an education, to an instructor, to a course team member, and say, well, the MOOClet is an email. Can you make different versions of these that are likely to work well for different groups, or just in general, you think are most likely to help? And so then you get a diversity of opinions. So what we actually did here was a 3x3x3 design. So there were 3 different subject lines, for example, return to course versus fill out a survey, 3 different intro messages, and 3 different response formats. One thing I should say is we did something here which I think is useful methodologically. If you cross these, you end up with 27 different conditions. And you can analyze the data like this, but actually each of these experimental variables we assigned randomly. So in psychology, this is known, and statistics, it's known as a factorial design. So the idea here is that we can, examine people who got subject line 1 and message 2 and response format 3, how are they different from people who got subject line 1 and intro message 1, and so on. But for now, we're actually going to analyze each of these totally separately, just looking at subject line, A, B, or C, versus, and in a way, just assuming the other conditions are noise. The big advantage of that is it gives us a lot of power to detect differences. If there are interactions, we can analyze for them, but we're not necessarily focusing on those. And in fact, interactions can be relatively rare, and it wasn't a big deal in this context. So in terms of now how we basically transition from starting off experimenting to doing some kind of partial personalization, the kind of key idea is to not see experimentation or personalization as a discrete process, but actually as smoothly varying into each other. So for the first 4,000 people, regardless of the age group or number of days active, we did a randomized experiment. We sent emails where there was a 33% probability of getting subject line A, B, or C. Well, you can actually think now about that 33% probability as being something like a prior probability. So if you think of something like Bayesian statistics, where you think that, well, you have some estimates, some subjective belief about the probability that A is the best subject line you could send, or that B is, we're actually, when we do a randomized experiment, is we're assuming that we think all of these are equally likely. And in fact, this is what gives you maximum statistical power. However, we're not just in a classical experiment or psychology situation. We actually want to help people dynamically. We're trading off this exploration against exploitation, helping students, helping instructors. So if we think about this 33% as a prior that A is the best, we don't think there's any difference between them. But after 4,000 observations, we should actually not have a prior. We should have a posterior. We should actually be able to update our belief. And so the kind of key idea here is that we then actually looked at how many people were responding to emails with subject lines A, B, or C. For example, 3.8% of people respond to A in the 18-22 age group. And we use this to then update the probability that someone will be assigned to each of these conditions. So I should be clear about what's happening here. After those 4,000 people, the next 2,000, 48% of them got subject line A, 22% got B, 30% got C. What's important to note is there's 2 senses of randomness here. Random is in all of them conditions being equally likely. We're not doing that. There's also random in the sense that for any given subject, what condition they're assigned to is chosen randomly. So here we're doing weighted randomness. So 48% of people can go into A, So there's a weight there, but for any person, you don't necessarily know ahead of time which one they're going to go into. And this is actually what allows you to do experimental analysis. So it's completely valid. It does reduce your power. So now how do we choose that 48%? Well, basically, what we did is say, this is a heuristic. There's some machine learning work that I'm doing now with Anna Rafferty at Carleton, basically looking at different algorithms for this because there are a lot of them available. But I'm just going to talk about the simple heuristic version right now. Well, what if we actually assign people to conditions in proportion to how much those conditions are helping them and how likely we think that condition is to work? So we basically say, let's take 3.8%, that's the proportion of people respond to condition A, and divide it by 3.8 plus 1.6 plus 2.3. And that's basically a rough estimate under some assumptions about how we go from prior to posterior. And that's where we get the 0.48 or the 48%. This is related to something that's been used in multi-arm bandits called Thompson sampling. It's actually different in a couple of ways, which I'm happy to talk about later in the discussion. So one thing I should say is you could do this without actually personalizing. You could just say, well, okay, let's just put people in conditions that are more helpful. And that's one thing we did. What we also did was essentially compute these probabilities separately for each level of the age group. So essentially what we did is we personalized, not by saying that everyone who's 23 years old is going to get version B, but by saying, well, you can actually personalize by changing the probability that someone gets a particular condition. So 48, 22, 30 versus 60, 12, and 28. That's actually personalization, but it's a statistical personalization. It's a probabilistic one where we're not giving everyone one thing or another. We're just changing the probabilities with which they get something. And so this is actually how we're getting this kind of smooth transition from experimentation to personalization, is because we really do view it as a continuum. There's no switch that you just flick and give everyone one thing. You're sort of smoothly varying in proportion to how much evidence there is that you should be doing something, and also in terms of how much it's helping. So this kind of lets us trade off continuing to explore with actually helping people in the course of exploring. And so in the follow-up study, about 590 people just received traditional assignment, so a 30% chance of getting the condition, no weighting, no personalization, whereas about 1,000 people received this weighted personalization. And so what you can see is the average response rate for random assignment was 4.5%, but it increased for weighted personalization. So about a 2.7% increase, so actually up to 60%. So the nice thing about this is that we are continuing our experiment, but we're also kind of trying to help people at the same time. So we're still collecting data and getting greater strength in our inferences, but we're also not doing the expense of necessarily helping students. So you can think actually of a whole range of policies, from traditional experiments to weighted experimentation, probability matching, and I'd be happy to talk about these more later. So I think I'm going to skip over this kind of quickly, but I think the main point of this slide is that this kind of idea underlying the MOOClet that experimentation and personalization are formally equivalent, and you should think about experimentation not as a discrete process, but actually as a continuation of instruction, where in normal instruction, we're just giving 100% of people into the experimental conditions 0% the control. It actually kind of really changes how you implement software. So I have more information there on how it's done. But the thing is, A/B testing is really huge these days. And in some ways, it's just like an experiment, but actually the way the software gets implemented is often actually very unnecessarily restrictive because there isn't this realization of this equivalence to personalization. So for example, here's how A/B testing is implemented in Assessments and edX, both really high quality research platforms. When you hit a condition, like what lesson to show someone, you randomly choose one of several options. That's fine, that gives us a randomized experiment, but that doesn't let us change the proportion of people who get a condition. It doesn't let us do personalization. Now, one step up would be to say, okay, let's actually use some experimentation rules, right? Let's put 33% of people in condition A, right? Well, that would be nice because now you can change dynamically over time. Well, okay, 30% in condition A, version 1, then it may be 50, 60. That's kind of helpful. So that's more flexible experimentation. On the other hand, it doesn't give you personalization. So what you then have to do is take one more step back and do something that looks kind of unnecessary. It says, let's actually just set people's sample and put people, assign them to have a variable value. The condition, the variable is set equal to A. Then, if condition is A, then show version 1. From a designer's point of view, this is completely unnecessary. It's actually dumb. It's unnecessary. Why are you sort of setting a variable to then go condition on it? You don't need that for experimentation. It's true that you don't, and that's why I think most A/B testing platforms don't have it. But actually, if you take it from the perspective of MOOClet, doing this then makes it trivial to actually say, well, let's just change those variables. Instead of the variable being set randomly, let's say that if pretest is greater than 50, then 80% go in condition A, 10% in B. If it's greater than 50, then 15% condition A, 6% in B. And so that simple switch, pretty easy to design pattern, anyone in A/B testing could actually try and do that. Makes a big difference in terms of being able to apply these machine learning algorithms and being able to do personalization. So that's some more information about it. I'll, again, skip over this very quickly, but in terms of the collaborative element of this, I think the key thing is that once you designate something as a MOOClet, it can keep changing over time. It's kind of like how Wikipedia was not necessarily very good in the beginning, but because there's this ability to keep changing and improving, that's what's made it into the most powerful resource available. The idea is that if you designate the hints in a particular question as a MOOClet, well, you can then actually crowdsource or request that people provide different hints. Psychologists, teachers, education researchers, these can then actually be added dynamically. So as we get new ideas, we can actually keep improving the hints. Then we can analyze not just what works well, but what works well for who, so that we're also learning algorithms and rules of personalization. And so that over time, you actually are constantly able to keep adding and improving. Another related point to this is that, as I mentioned, there's this idea of thinking about the probability of assigning people an experimental condition as a prior estimate. Well, instead of doing everything equally, maybe you can actually elicit from different experts, like the instructor, from researchers, how likely do you think hint 1 or 2 or 3 is to work? Then you can actually weight these priors to actually start off maybe 10% of people get hint 1 and 90% get hint 2. This kind of gives you best aspects of Bayesian inference, where if your prior is correct, then we quickly get to the truth and students get the best version. If your prior is incorrect, though, you still have the opportunity to learn that. With time, data will overwhelm it. Without that kind of continuous way of thinking about it in a MOOClet, instructors would just say, well, I think hint 2, 90% chance is right, I'm just going to stick it in. And that's what they run with. We never actually learn what does and doesn't work. On a related note, I've started working more extensively with assessments.org. And one reason is because they're actually allowing people to sort of propose and crowdsource these studies. So you or any researcher can now go, because there's support from an NSF grant, and actually propose a study to be embedded within these online math exercises. So these are run often with middle school students, but you could actually also just embed assessments using LTI or learning technology interoperability. You can embed it into edX or Moodle or whatever you like. So you can actually propose studies and then actually have these vetted to be run. And so one thing that we're moving towards here is, how would you think about using competitions, where the experiments are the ones that actually judge the versions proposed? So we give people a common set of materials. We tell them where they can change, what are the MOOClets that they can vary, and we tell them what outcomes they're trying to maximize. Then people propose the experiments. They might undergo review. We might get some priors from experts, but then we actually evaluate them by putting them into randomized experiments embedded within a MOOClet. And so this is the direction we're pushing towards now. Let's say some additional example MOOClets.
Oh, sorry. I didn't mean to interrupt you. I thought that you were pausing for questions.
Yeah, sorry. I'm gonna wrap up right now. So basically just showing some examples of MOOClets that have been run, adding messages, links that people click, and then they get questions to help them think through a problem. Embedding learning strategy tips. This is a biochemistry MOOC that's running right now. Motivational videos, actual modules that we've just added onto some courses in HarvardX. Yeah, cool. And so just to summarize, I kind of mentioned that the key idea of this MOOClet framework is really to enable researchers and instructors and others to collaborate. So we designate these modular components as targets for improvement, practically, as laboratories for education psychologists, and then as intelligent agents that can adapt using machine learning. We can actually discover now how to personalize through experiments. This is an extremely hard thing to do, and I think the MOOClet framework doesn't solve this problem. It just makes it easier for researchers out there to make progress towards it. provides analytics and data in real time in a way the instructors can see what's being given and researchers can know what they're getting. It also provides an abstraction for reinforcement learning, where we've got instructors on one side, experimental researchers, and then machine learning people all working together to optimize resource. It's actually really easy to implement. I've done it within edX. I can give you examples